You are listening to the Archaeology Podcast Network.
The Archaeology Podcast Network is sponsored by Codify, a California benefit corporation. Visit Codify at www.codifi.com. Looking for great gift ideas? Visit codify.com/APN. That's codifi.com/APN for an amazing Cyber Monday promo code just for listeners of the Archaeology Podcast Network. That's codifi.com. Hello and welcome to the Archaeotech Podcast, episode 40. I'm your host, Chris Webster, with my co-host, Chris Sims. On today's show, we talk to Ben Marwick about a different sort of forum coming up at the 2017 Society for American Archaeology meetings in Vancouver, Canada, next March. Let's get to it. Okay, welcome to the show, everyone. We are on right now with Ben Marwick. Ben, how's it going?
Good, thank you. Great to be with you.
Yeah, thank you. So we're going to talk to Ben, and honestly, Chris and I are just going to kind of roll through this and ask Ben questions as it suits us, because we're going to have him introduce himself and talk about what he's doing. But I first became aware of what Ben was doing because of Twitter. I saw some tweets as there's always a flurry of tweets around SAA submission time. And, for the deadline for the submissions, and people saying, oh, I got this in, and he had some pretty interesting tweets related to what he's doing at the SAAs, so I wanted to talk to him about that. So, Ben, first tell us a little about who you are and, where you're at and what you're doing.
Yes, sure. So currently I'm a senior research scientist in the Centre for Archaeological Science at the University of Wollongong in Australia. And I'm also an associate professor at the Department of Anthropology at the University of Washington. And the idea for this activity at the SAA really came out of a conversation with Matt Harris, who's a CRM archaeologist. And he and I are both very keen users of the R programming language for doing archaeological analysis. And he's really into, sort of sharing his work with other people. And he has a very active blog with lots of interesting projects that he posts on it, and some of them are serious archaeological studies, and I saw one recently about Pokemon. So he sort of really tries to bring art to every sort of analytical topic. So he and I were chatting and thinking, like, what can we do so that other archaeologists can enjoy the same kind of benefits of more efficient, reproducible analyses, and also we're looking at a broader advantage beyond like in the individual to the discipline as a whole. So we thought, well, let's try and do something at the SAA, and we sort of chatted about a few ideas, and he had an idea for a training workshop for novices, which is kind of an extracurricular thing at the SAA. So it won't appear in the program, and it's not not a sort of scheduled event, but the SAA have helped us to organize a venue and help with the logistics and promotion. So that will be a 4-hour session that we draw the curriculum from software carpentry and data carpentry, which are two international non-profit organizations, not for archaeologists, but for scientists in general. And they put a lot of effort into designing lessons and workshops for researchers of any discipline to get some skills in using tools on their computer to make their research more efficient.
Okay. And
they really have a focus on especially tools that are free and open source. So you don't have to pay any money to buy them. And every part about the tool is available for you to inspect or modify, this kind of thing. So I've been, I've taken these courses as a learner, and now I'm also a certified instructor with software and data carpentry. And I run these workshops here at the University of Washington and at the University of Wollongong as well. And so we thought we'll bring something like this to archaeology, and we will take some of the pedagogy of software carpentry, which is amazing, by the way. If you have a chance to browse their website, they've really put a lot of effort into how to teach people effectively things on computers. They really have a lot of innovative ways for teaching and learning stuff. So we're going to bring some of those techniques and the R programming language to archaeological questions, and we're going to have this, Matt and I will lead this 4-hour workshop. Okay. To teach people how to get started on using R for archaeological problems. So a lot of what you see for people self-teaching, my students and colleagues trying to self-teach, and a lot of the material is, it's for ecology or genetics, and it's difficult to relate to archaeological problems. And so we're going to try and sort of fill that gap and bring some specific archaeological applications, and invite people to bring their own data with them to the workshop, and we can have a bit of a look at it. So their goal is really to sort of lower the barrier to getting started on using a programming language for doing archaeological analysis. And our motivation for this is pretty, I think it's quite interesting. It's really something both Matt and I know a bunch of other archaeologists are really into as well. And the main idea is that, archaeology, like many sciences, has become really complicated. And most archaeology you can't do with a pen and paper anymore. You really need a computer and a spreadsheet and some other software tools to get anything serious done. On one hand, this is great, because we do really exciting work and we can answer questions that are complicated and interesting. But on the other hand, a lot of the turning of the handle of the analysis is kind of obscure and hidden from view, and we don't even know really what is going on a lot of the time behind some of the software that we use. So on one hand, the computers enable a lot of things, and on the other hand, they also obscure a lot of what we do. So, for example, a simple case, right? We often work in Excel or a spreadsheet kind of environment, and we do a lot of clicking of things in Excel, and we might do some linear regression and a lot of clicking around. Right. And then at the end of our working session, we have some results, maybe a p-value, maybe a plot, and we paste it into a document, and that's it. Circulate to whom we owe the report or for publication or whatever. But if we have to kind of backtrack or reverse engineer, we might find ourselves really struggling because all those clicks that we made in Excel are gone. There's sort of an ephemeral sort of residue of our analysis trail. So this is problematic. And in archaeology, this is kind of inconvenience. But in some other disciplines, like economics and psychology, there have been some really scandalous problems where people have done some analysis in Excel and made a mistake and not been able to see it at the end of their analysis, and then someone else has got a hold of their data and tried to sort of reverse their way back through from the finished result back to the raw data, and found out that some critical, some cells were missing, some rows were missing from the analysis, and it completely inverts the result, which is really, really sort of scandalous and catastrophic.
Yeah, there was a pretty famous example of that recently, wasn't there? Just a couple of years ago, I thought.
Yeah, that's right. The economists Reinhardt and Rogoff,
right.
probably the most notorious example of that. That's really a motivating case for me and several other people I know. So we're concerned about this kind of thing in archaeology, and so far we don't have we haven't had any great scandals like that. But we want to make sure that we're not going to have any. So that's why a programming language we think is kind of a better way to do archaeological analysis than what is the normal current way of a lot of sort of clicking and so on in programs. Like, it doesn't really matter what the program is, but we often are most people are familiar with Excel or SPSS and so on. So we're looking for a change really in the way that scientists work in general, and specifically for archaeologists. And we're looking for people to get out of these kind of clicking things and into an environment where the instructions are written down, like as a script file, for both a human to read and a computer to execute. And then when you write down your analysis in this script file, then it's available for you to look at again in the future, and you can see what you did, a week or a month ago if you need to redo it or modify it for another project. And then someone else also, can see what you did. So often, we run into this case where someone has published a really interesting paper and we're really excited about the result, and we can immediately see some application to our own work. And then we look into the paper and we see there's just not quite enough detail there for me to really use this. The method section is too short, or, there's just something missing that I can't quite get a handle on it. And then you think, well, I could invest a lot of time kind of reinventing what they've done. I could try to contact them and ask them if they can help me, or I can just carry on doing what I'm doing. And often the inertia is so strong, we end up just looking at it and going, well, that's cool, but it's too much for me to implement that myself, so I'm just going to
yeah.
But in the case where someone has provided a little bit more information, like in the form of a computer script file or something like that, you can then very easily implement their work onto your own data set. And so I think, this is a key kind of bottleneck in the progress of archaeology as a discipline. There are a lot of great ideas and brilliant people doing innovative work, but it's very difficult for us to kind of incorporate these clever new things into our own work, because we don't really have a very transparent mechanism for sharing analyses. And so people like Matt and I and a bunch of other people who are already working like this, have kind of settled on the programming language called R as the way to communicate the complex details of analysis with each other and with people, with ourselves, our future self, when we might want to come back and check on what we've done or extend it. And we're seeing this in other disciplines, like biology and ecology and political science and psychology. There seems to be a bit of a change for people switching toward using a programming language to run and document their analysis. And we see, R is just one language that's very popular in science. And another language is Python, and there are also a bunch of archaeologists using Python. And that also is a free and open source language that anyone can use. So Matt and I have chosen R because from our point of view, we see most archaeologists using R, and I'm trying to keep track of a list of papers that people publish internationally in any journal where they're doing an analysis in R and they're making the R code available. And at the moment, that's happening at a rate that I can manage to record it. But I'm hoping in the future the rate of that will pick up, and I won't be able to record it by myself anymore. So that's kind of the vision. And then when a paper is published, we'll just immediately know that there's an R script or some kind of compendium available, and we can dip into that and see really what's going on and then use that for ourselves.
Okay. So it sounds like, is this workshop sort of like the MSU Digital Archaeology Institute workshop they did a couple of months ago? But that's like a week-long thing. I understand that. But are you affiliated with them at all or working with them? Because it sounds like you guys have similar goals.
Yes, that's right. So I'm not officially affiliated, but I'm really interested and really admire the work that those guys are doing. And when they had their workshop on, I was, watching the YouTube stream the whole time. And it's people like, like Sean Graham, who is also an archaeologist who's kind of a very serious and advanced user of R, who's really an inspiration to the role of the rest of us, because he's really sort of leading the way. And a lot of those guys at that program are kind of pioneers in this thing, and we've just chosen one small element of the archaeological process, the sort of data analysis, to really. That's where we see that we can sort of make a difference and try and make things a bit easier for our colleagues if we feel that by using a programming language, things can be done more efficiently and more transparently and more reproducibly. And this has a sort of significant personal advantages as well as like kind of communitarian advantages for the whole discipline. So unfortunately, we just have 4 hours rather than the week of the digital archaeology thing. And so the goal is really just to give people kind of a gentle on-ramp to using R and help them sort of navigate their way through it, and where can they get help and lower some of the barriers to using it by themselves. And it's like any sort of serious enterprise, it's not something that can be mastered in a short time.
Right.
But it's something that really inspires a lot of fear and anxiety in people, especially in archaeology, where most of us are not trained in any kind of computer science or anything like that, and we feel a little bit of anxiety about things that are mathematical or computational. And so one of our big goals is just to make it not so frightening and make it comfortable and normal, and give people a few key ideas and tools to just like the 20% of the things that do 80% of the work for most people.
Right.
And then you will feel comfortable to sort of find out the rest by yourself after that. That's the goal with the workshops.
Yeah, and kind of thinking about that, because it made me think. We got all these. You have this workshop, and then the MSU had the whole. It was actually like 2 years worth of two different week-long workshops where they're teaching people all these things. But my question is, in archaeology, is mentioning like the 80-20 rule for percentages, because we talk about that a lot in Codify, is like you solve for the 80%, because that's kind of what everybody's doing, and then you start fixing the oddball outliers. Well, keeping that in mind, I mean, rather than eventually, people have to learn these programming languages early on, but eventually, could some sort of app or something be developed that, not necessarily just an app for like a tablet or smartphone, but, for a computer that just runs these, you enter your data and it runs these common things. So you don't actually really kind of have to learn it. Like anybody can just pick it up and say, okay, I have this data set. I need to put it into this, container, and I will get this result, or run these different things on it.
Yes, that's a very interesting question, and I think there's a couple of different, depending on your perspective, a couple of different possible answers. So, on one hand, I guess I would say that R is kind of at a state already where it's a bit like that. where you might have a data set and you have a couple of things that you want to do. And so one of the things about R that is kind of unique as a programming language is this huge kind of library of packages that mostly have been contributed by other scientists to do that kind of thing. Like I've got a thing analysis I need to do. I don't want to have to write hundreds of lines of code every time, so I'm going to bundle it up in a package, and then I just need to type one line of code, and that will run all this other stuff in the background and produce my result. So in the course, for most people who are using R, they will depend on probably a dozen packages that they know really well. And so they just need to write a few lines of code to get that 80% of the work done, because all of the details is done in the packages that other people have prepared. So on one hand, that kind of already exists in R, this idea that there's sort of pre-packaged apps that are available. And to me, that's what makes R the most compelling language for an archaeologist to use, is you don't have to bother with a lot of computer engineering. A lot of the work has already been done for you by other scientists in other domains. But on the other hand, I think another answer to that question might be that well, why should we use R at all? Why aren't we just using Excel, SPSS, which are those kind of apps where you just sort of make a few clicks and you get the plot and you get the p-value and so on. And I think the reason why I don't think that's a good answer is because it's too opaque. A lot of the things that are done in Excel and SPSS, we have no way to know what kind of parameters have been set in some of these more complex algorithms. And it's something like R, where we can conveniently use a package to sort of shortcut hundreds of lines of coding. We still have the option to dip in behind the scenes and see what's going on and see what parameters have been set in sort of complicated regressions and so on. So that's the advantage of working with an open source package like R or Python compared to a closed source package like I think Excel and SPSS and the program PAST is quite popular as well. Closed source means you don't have the option to see what parameters have been set or to alter them if you want to. So then you're working in kind of a bit of a black box situation where you don't have the option to see what's been set for you. So I think speaking from my heart, I think R is already quite close to that situation where you have a series of apps that are available for you to use that simplify things a lot. So you don't need to get bogged down in a lot of the details of how a computer programming language works. You can sort of, I think, skate across the surface of a lot of the mechanics and focus really on doing the analysis and answering the intellectual questions, because a lot of that work has been simplified by people already who write these amazing packages that do lots of really useful analyses.
Yeah, and I think that's a really good point on keeping yourself immersed in the process of doing these computations and the process of keeping the statistical analysis as part of your scientific research question and your research design.
Yeah, that's right. And I think there are many different kinds of computer languages, and it is possible for someone to choose a language. I think C++ is an example of this, where you can become completely absorbed in the engineering process and managing memory and sort of details that really are very far from the scientific question that you're trying to answer. And languages like R and Python are really aimed at the working scientist, who doesn't really want to get bogged down with managing memory and protecting and unprotecting data objects and so on. They have their intellectual question foremost in their mind, and that's their primary motivation. They just want to code the minimum amount possible to explore an answer to that question. And so that's why I think R and Python are great options for archaeologists who for the most part are don't want to get into the weeds of computer programming, but they do want to have access to, say, novel and exotic techniques that suit the nature of their data, for which Excel, there's no button in Excel to do some of these things. And so I think these languages, especially R, is like a great, it's sort of designed for that purpose, like for the working scientist, and with these packages that add on that sort of hide away some of the complexity, but still keep it available to you if you need it. And I know there are some archaeologists who will look into a package that has been written by a geneticist or something like that, and they'll just dive right down into the bottom of it and find a function that they want and then tweak it a little bit to suit their archaeological application, and then just use that, which seems to me to be just this kind of an ideal state of knowledge transfer between disciplines, where something that has been developed by a geneticist can be used by an archaeologist without too much, having to get distracted by learning programming, engineering, and so on.
Yeah, I'm talk about what a powerful multidisciplinary tool that R can be. Well, I think that that's a great point to take our first commercial break, and we'll be back with more with Ben Marwick.
Hello, APN listeners. Today we have some exciting news. The Center for Digital Archaeology, PCS, and Codify have teamed up to create an exciting new online training program built especially for you. Visit digitaltraining.site and you can sign up for free interactive office hour sessions to get help and share ideas about everything from digital photography to drone usage in archaeology, and even tips and tricks on how to prepare for your next job interview. We're offering deep dive 2-hour webinars and intensive single-day workshops so that you can truly level up your skills. This is cutting-edge training provided by experts in the fields of digital imaging, cultural resource management, business practices, and more. Courses will fill up fast, so visit digitaltraining.site today and see what we have in store for you. That's digitaltraining.site. We look forward to learning with you.
Okay, we're back. So Ben, one of the things I wanted to ask you about, we've talked about putting data in and getting results, but let's dig into the meat of that a little bit for people listening to this podcast that don't have any idea what we're talking about, and maybe this is their first exposure to this sort of thing. Because unless you're like a grad student or something right now working on something, you're just not exposed to some of this in your daily life, especially like cultural resource management archaeologists. Often we just write a report, turn it in, and there's nothing else that gets done with it. Now, that's not always the case, but in a lot of times that is. And perhaps if people understood how to do some of these things and what they have to put in versus what they can get out of it, maybe it would not seem so like such a monumental task. They could just do it, get some information, and include that in the report, or possibly in a presentation or paper at some point in the future, or a poster or something like that. So what kind of results are coming out of this? Or maybe better yet, what kind of data goes into these R analyses, and then what kind of results do you get out typically? I mean, I know it depends on what you put in, but
Good question. The short answer is almost everything and anything, but that's not very helpful. So let me give it a little more detail. So in fact, Matt and I have a second event at the SAA, which is a forum, and the title of the forum is How to Do Archaeological Science Using R. And basically, we've arranged a bunch of people who are doing these kind of things, doing archaeology using R in really interesting ways, and we're asking them to give like really short presentations and take questions to kind of showcase like exactly what are they, like what kind of data is going in and what kind of results are getting out in their work with R as an archaeologist. So that's going to be one kind of answer to this question, is this forum where we showcase a bunch of people who are archaeologists who are using R day to day to do archaeological stuff. But to be a bit more specific, so I think like anything, so you can make a plot in R, any kind of plot that you sort of see regularly, and even very exotic ones are possible without too much effort, I think. All of the basic things of a site report or a survey report can be done preparing maps, doing in most kinds of basic spatial visualizations and analyses are possible. All of the usual kind of summarizations that we do in archaeology of counts and quantities are possible. And we love to do comparisons, and are there significantly different amount of certain kinds of artifacts, or different sizes, or different differences in their various other quantities. So all of this sort of very traditional, basic descriptive, exploratory data analysis and kind of hypothesis testing types of statistics. Are there significantly more sites in this landform than that landform, or are the artifacts here significantly different in certain attributes from one time period to another? All of these things are fairly like common, basic, and I think fair to say trivial to do in R. So, and in this kind of running list of publications that I'm trying to keep of people doing archaeology with R in their journal articles, they range from fairly standard sort of site report kind of things where someone is using R just to make a graph of how many bones are in each layer kind of thing, through to slightly more complicated things. And a couple of them are to do with like analyses of radiocarbon dates. And there are a bunch of people. Enrico Creamer has been quite productive using R to work on radiocarbon dates of a region to understand patterns of population dynamics, which is really interesting stuff. And he makes all his code available, so it's quite nice to see what's going on. And he's really taking advantage of packages that have been written by paleoecologists who also work with radiocarbon dates to do calibration and some probability distributions, the kind of things that we often like to do in archaeology as well. Okay. So dating is the thing that's, and often we go to OxCal or BCal or a website like that for calibrations. All of that can be done in R, and there's some really nice kind of built-in visualizations for visualizing radiocarbon dates from archaeological sites. And Thomas Dye in Hawaii has done some really interesting work just describing rhythms of Hawaiian social stratification as well. So looking else on my list, so we've got really basic stuff, site reports and survey reports that a CRM archaeologist could use. And one of the really useful things for CRM archaeologists who might be doing quite similar kinds of analyses in repeatedly in sort of neighboring areas or for different clients. They might write a script for themselves that is basically their sort of custom app for doing the analyses that they like to do frequently. And all they then need to do is just supply a new set of data. So that could be a new bunch of Excel spreadsheets, one spreadsheet or thousands of spreadsheets, or shape files, or output from a GPS, or files from most other kinds of software can go into R. Even there are some people, some of my students also working on image analysis, so taking photos of artifacts and then using R to kind of quantify like the outline of the artifact and do statistical analysis to classify. And people like Andy Bevan in the UK have been using R with 3D images as well, so taking 3D models of artifacts, and doing really interesting kind of classification analysis of those. So it's kind of like it's a bit cliche, but it's kind of limited by your imagination really, and also how much kind of time and effort you're willing to put into it. There are a few people in archaeology that are working on texts. So they're taking the text of reports, and you can imagine this would be really useful in a CRM context. If you have hundreds of grey reports in the grey literature, you don't really want to read them all, but you want to see like how often is a certain site mentioned or a certain culture phase, right? And you've got them all in PDF. You can read them into R, and then you can have R kind of do like a text analysis and tell you like how many times is this site or this phase mentioned, and or you've got tables and tables of data in PDFs. You can read the tables into R, and then have them as if they were like a spreadsheet style thing, and sort of do summaries and and basic sort of exploratory data analysis and make some graphs and stuff using R. So really, it really is extremely versatile. All of the basic stuff that we all do day to day in Excel is something that can easily be ported over to R. And then things that are very sort of complicated and novel that perhaps no one has ever done in any other application. You can sort of program it from scratch in R. So I think maybe I'd be happy to circulate my list of papers, and I think that's a great way for people to sort of browse these papers and see what looks familiar or useful, and then they can have a sort of look into the code that comes along with the paper and see like, oh, so that's these are the kind of ways that stuff done. And for me, most of there are a bunch on there, and I can highlight them that are these kind of standard like excavation report or analysis report, where most of the methods are fairly conventional. And so the unique thing is really just the use of R rather than Excel or SPSS, and that's really easy for people to see. Like, how can they translate? Okay, I'm already doing this kind of analysis. What would it look like in R? And then, okay, here's a paper where that has been shown. How do we do this kind of bit of zooarchaeology? How do we summarize how many taxa per excavation unit? Okay, here's the code where that's done. That's how and then you can directly adapt that. Yeah.
Nice.
Well, your description of CRM archaeology hits a little too close to home, I think, about it all being relatively similar data sets. And we could just create something that we can just drop in project after project. That's absolutely true.
Right. Well, I know
Yeah.
it's not quite right. Well, I know it's not that simple, but I know that there's a lot of potential for gains in efficiency in that kind of workflow. And even in a research context, people are doing a lot of the same things. The sort of first 10% of a project is just sort of getting organized, and a lot of that is very, very homogenous from project to project. So there's a lot of gain for efficiency, and I see I follow a lot of people on Twitter, especially, and Twitter is a great place for learning about what's happening in R. In other disciplines, and who are doing things like CRM, like people who work in public health, like managing hospital data and stuff like that. And so they design these kind of templates for themselves, where the report is kind of, there are sort of boilerplate bits of the report, and then there are bits that change from job to job. And then they have this R code that helps to kind of populate the bits of the report that are unique to each job. And I just see huge gains in efficiency in the way people are using R in this really innovative way to streamline their workflow. And I think there's a lot of scope in archaeology to benefit like that.
But yeah, and like you said, it helps to have your data organized. I know it's handy that you can actually, R will read a PDF. I'm assuming the PDF has to be OCR'd already so it can understand what's on there, unless R does that.
Yes, that's right.
Yeah, okay. So that's handy for legacy data, and it's actually handy for people in CRM recording things now that are just producing like Word documents and Excel tables, and they can have that stuff. They can put that into R and just have it searchable. However, I like the thought of, like my company, the project we did last year, we recorded completely digitally. So it started digital and was just, all the data, all the sites were in a huge Excel spreadsheet, and a bunch of little ones as well, but nearly everything was in one master spreadsheet that I kept just, in a couple different locations so we could go back to it. But that would be easily searchable because it was born digital and, everything was right there. And also thinking about, the software that we're developing with Codify, that's, we're debuting the first part of that this week, but we have lots of grand plans for really advancing this into the future and thinking about stuff like that. So somebody could take their data set and maybe that's kind of why I was interested in the app question earlier. Can you create something that uses these analytical tools so we could build that right in, and you could just do it, at any one point in time, you could go hit a button and say, run this common analysis that I like to do so I can see what's going on, and then get your data result there.
Yes.
Yeah.
I think it's great to hear about your use of like a born digital workflow, and I see, and this is going to be a huge time saver for people who are not already doing that.
Right.
And I was looking through a project, and I'm not quite sure of the exact pronunciation of his name. It looks like Nehemi Strupler. With the German Archaeological Institute, and they had a similar idea: born digital, like digital data collection, and then they used R in combination with a sort of app in R that is called Shiny, which I think is probably the closest thing to what you're suggesting, where you design, and it ends up being a web app which you can host, on your own server or on the internet. In which you kind of, you might upload like your day's survey data, for example, directly out of your handheld device. And then a couple of clicks and you can get a map, and you can get some summary distributions and, how many sites were recorded today and how does this compare to the overall set. And so then you have this kind of app that you could quickly generate. Firstly, you can get a quick look at what happened over the day or the week or whatever. And then you could use it to generate a report, like an HTML or PDF output, which you could then, email on to your sort of project manager or client or whatever, who could get a quick summary of what's going on. So now suddenly it becomes very trivial to sort of develop an app using this Shiny framework, which is designed for R, to these very kind of aesthetically pleasing and simple to operate web apps. So, you might have someone on your team who's developed it in R, but then anyone else on the team who doesn't know or have any interest in R can operate the web app just as if they were operating their email, or a simple website, and get insights into their data and then be able to communicate with other people on the team very easily. So I think Shiny is going to be a big thing, and I see that being used a lot in other fields and disciplines. And I think it's going to be something in archaeology as well, especially in this setting where you need to work with people who who are comfortable and happy using R and people who are not using R. And then you need to be able to sort of have a flow of information between those two. And this app Shiny is a great bridge between those two groups in a team.
Nice.
Nice.
What does R cost?
Well, just your time.
And how is that possible?
It's a good question. So it's free and open source, just like Python and several other programming languages. So it was originally developed by a couple of academic statisticians in New Zealand, in fact. And the name R comes from the first letter of both of their first names as kind of a joke. So it was developed as a research project. For research contexts, grant funded as well as volunteer work, and then it sort of has blossomed into this kind of international community of people that mostly using it in academic settings, but also with the growth of this thing that is called data science, which is kind of like statistics plus applied math plus incredibly massive volumes of data, usually related to the internet. People are taking their skills now that they learn in a statistics class at university and then getting a job as a data scientist, for example, with Facebook or Twitter to analyze user patterns and better target advertisements and so on. And so those kind of people are taking their R skills that they learned in an obscure class as an undergraduate, and then they're developing the program further and contributing to the core of the program and writing packages that that archaeologists like us can find really useful. So, probably in the last 5 years, it's been a really exponential growth, and there's been because a lot of big companies are employing, commercial statisticians they recognize, okay, this program R is really central to us continuing to make a profit from advertising, or whatever. So we're going to make a contribution back to R. So they will fund people, PhD students to work on projects that improve bits of R or write packages or fund, contribute to conferences. And in fact, the workshop that Matt Harris and I are organizing for the SAA, we've got some sponsorship from Microsoft because they're actually huge fans of R, even though it seems, Microsoft is very sort of commercial and profit oriented, and R is free and open source and very sort of, ideologically opposite. Microsoft have a huge investment in R as a popular and successful analytical package. So to get it on your computer is completely free. But I would not recommend to anyone to use R by itself. There is a second program that's really essential for I think a happy and productive experience with R. And that is also free. And it's called R Studio. And it was that time, when I've been interested in R for a long time and would sort of try it out periodically, just R, plain R, and then feel very disappointed after a minute or two. I just couldn't do what I wanted to do in the time that I felt I should be able to do it in. And I would get very frustrated and then quit it and go back to using SPSS or other things for a year or two. And then I would check in it again a year later. And then in 2011, this program called R Studio appeared, and I thought, I'll give this a go. And finally, I thought all the things that I didn't even know that I needed, they were there. They made it so much easier. And I just felt, okay, finally, I can handle doing this for more than about half an hour. I'm ready to go cold turkey on Excel and just commit myself to this kind of R thing.
Yeah.
So if anyone is kind of R curious, I would suggest it's to not go with R by itself, because that's really going to be a heartbreaker. Go for R plus R Studio and work with R Studio. And that's what we're going to be teaching in the workshop, and what I think most people are using, because it really makes it so much easier to sort of do the things that you want to do. And there's a lot of there's a lot of things that make it easier to get into R than it used to. So that's why I said that the answer, what's the cost, is just your time. It's either the time to take a course or attend a workshop. And a lot of the material, there's a lot of really wonderful materials online for self-teaching. And a lot of it is free to access as well. So, for example, the software carpentry and data carpentry lessons are all completely open and online, so you can sort of step your way through their materials. They're focused on mostly other disciplines, but a lot of it is translatable without too much effort. And so that's really useful stuff for becoming familiar with R. They've put a lot of effort, especially into the total novice. They're making things accessible to someone who really doesn't have any interest in programming languages, but wants to, up their game with their data analysis and become more efficient and reproducible. And then, of course, there's a whole market of paid courses that you can take online or in person that has really kind of blossomed in the last couple of years of to meet the demand of people who are like, oh, what is this R or Python thing? I really should kind of get my head around it. What's the quickest way? So I don't really have any recommendations. I don't have any experience with the paid stuff, but especially the software carpentry and the data carpentry, which is all open and free, is really good stuff, and I think really well suited. Data carpentry, especially, it has a focus on scientific application. And I think for archaeologists, is a great sort of set of learning materials that you can just kind of work your way through at your own pace. It's all very hands-on, and everything is available for you to kind of reproduce the lessons and the results as you go. So. So if you're willing to put in that kind of time, a little bit of time, then really the cost is negligible to getting started in R. And one of the things about the community of users is, I think, it's sort of uniquely friendly. I think, of course, there are some pointy corners to it if you look and poke, but for the most part, people are generally really friendly. And if you take the time to articulate your problem, they will take the time to answer it for you, even when there's no benefit to them other than the satisfaction of another person who's sort of doing cool things with R. So there's a really neat. It's another free service. It's a question and answer website that is called Stack Overflow, and you post your question there, and then people evidently stumble over themselves to rush to answer it. And I've really this has been a really useful place for me. And if I'm working on a project or a paper and I get stuck on a bit of code, I know what I want to do, but I can't seem to write the code for it, and I will shrink it down to a really small example. I don't need to give away any of my actual use case, but I sort of reduce it to a small example, and I post it to this Stack Overflow question and answer website. And then people sort of jump on and have a look and answer it and give me suggestions. And sometimes within hours, I've got sort of code that I can use that someone has volunteered for me. It's kind of a game. You win points if you get points for good quality questions and good quality answers, and the winning answer wins points and so on. So it's kind of a fun thing for people to work on. But there are a lot of big names in the R community, like practicing scientists and practicing. People who work in industry or use R, they're quite active, answering people's questions there. So this is a great resource for people working with R as well. So I think there's a lot of sort of warm fuzzies in the R community, especially for scientists who sort of got problems and they're willing to put a bit of effort into getting a solution. So that's another great thing about getting started in it, is that you don't have to look far to get some good help.
Right.
That's amazing. And that's a lot of great info there on, how to efficiently use R and how to learn how to use R. I guess a couple quick questions before we wrap up this episode. What do we need to know about signing up for the workshop? And also, what should people bring to the workshop?
Yes, right. Good question. I think Matt and I will certainly be willing to take sort of reservations for tickets to the workshop directly by email, and I think we may also be able to get the SAA to sort of advertise a sign up as well. But I think the simplest way is just to email us directly with it to say I'd like to come. We will be, because it's kind of an extracurricular thing. We do need to charge a fee for a ticket to help to cover the cost of hiring the room, which is surprisingly expensive. But we've got some nice support from Microsoft that I mentioned, and also RStudio, who make that program that I mentioned. So they're giving us some support so we can keep the ticket prices fairly low. So we'll set up a way of purchasing tickets online. But for now, I think it would be just fine to send an expression of interest by email to Matt and I. And sorry, what was your other question? What to prepare? How to prepare?
Yeah. What to bring?
What should they bring?
Right, to bring, I think the simplest thing to bring is obviously a laptop with a fully charged battery, because it's really going to be a hands-on thing, and we want you to be able to be typing along and working on the exercises, and there'll be a few multiple choice questions along the way and this kind of thing. So a laptop, and then have also installed on the laptop the latest version of R and RStudio before you come into the workshop, because that can take a few minutes, and we don't want to sort of use up the workshop time waiting for things to download. We want to get right into using and learning R. So a laptop, fully charged battery, R and RStudio. really the compulsory elements for the thing, and other things would be bring a friend, because it's going to be more fun if you've got someone to join you on the journey. And you might even want to bring your own data set. If you have an Excel spreadsheet of something that you're working on at the moment, bring that along and test it out in parallel with the things that we're working on in the workshop. Try and read it into R and try and make some simple plots and maybe recreate some of the analyses that you might have done in Excel. We can do that in the workshop using R. So that's it. I mean, just bring a working laptop and a fully charged battery, and R in our studio. And of course, we have some instructions for that we'll send out to all the participants on exactly where to go to get R in our studio. But it's fairly simple. If you just Google to install R or install R Studio, you will probably get there without too many clicks.
We have links to those in our show notes, so people can go look there too if they're interested right now. So, and we'll also get Ben's and Matt's email address and get those in the show notes as well. So clearly, since Microsoft is sponsoring this and supporting it, it runs on Windows machines. But does this run on Mac as well?
Yeah, so it's cross-platform. So it will run on OS X for the Mac, and it will run on Linux, any version of Linux, and it will even run on a very obscure operating system called Solaris. Yeah, and it's kind of a bit of a joke in the R community that if you are a package developer, you have to make sure your package will work on the Solaris operating system, and no one really knows why. But yes, it definitely works on Windows and Mac and Linux. So it's totally cross-platform. And one of the really neat things is that if you're working on Mac and you write a script that does something, and you send me your script, and I'm working on Windows, it 99.9% of the time it'll just work exactly the same. So that's really nice. Often we come up with these problems. We're like, well, I'm on a Mac, I'm on a PC, it's not going to work. How do we solve this problem? And it's it's sort of compatibility. But this kind of cross-platform environment really smooths out some of those wrinkles in collaboration. Yeah.
Okay. Well, cool, Ben. Thanks a lot for telling us about this, and hopefully, when you guys are ready for signups, people can check that out. Follow Ben on Twitter. I'm sure you'll be putting that out there, that information, when the signups are available, and we'll have your contact information, your Twitter, and all that in our show notes as well, so people can see that. So head on over to that page and check it out. Was there anything you think you wanted to mention that we didn't talk about the workshop real quick?
No, I feel like I've given a pretty good introduction to what's going on, and I'm happy to take any inquiries by email if anyone wants to know more.
Okay.
Thank you.
All right. Well, sounds good, Ben. Thanks a lot for coming on the show.
Thank you.
All right. And we're coming right back after this short break for our App of the Day segment. Professional Certifications for Scientists, or PCS, aims to provide practical educational videos, field guides, knowledge tests, professional certifications, and employment connections to professional scientists everywhere. Check out the resources page for useful links, a directory of CRM archaeology firms in the U.S., and a link list to state site forms. Find PCS resources at www.pcscourses.com/resources. PCS, a place for good scientists to become great science professionals. Okay, we're back for our App of the Day segment, and we're going to bring a couple apps to you right now. We don't always do these because sometimes we have longer interviews, like the last episode of the Architect podcast. The interview was just too good to stop him. So, we just let Peter run on, and it was a great episode. So, but anyway, so the app of the days today, I've got one that I'm doing for a company called GoTenna, and that's GoTenna. And basically, GoTenna is it's a device. Okay, it looks like it's a stick that's I guess probably when the antenna is not extended, it's about probably 5 to 6 inches long. And then when the antenna is extended, it's probably up to like 8 inches long. And you're intended to strap this onto your backpack so it's on the outside, like on that loop a lot of backpacks have on top. And what this is basically is it works off the similar principles that, say, the handheld radios do out in the field. Those ones with the FRS signals that go long distances, like 5 to 10 miles, because it's a really high frequency. So the high frequencies, they don't degrade as fast, and it can get through a lot of other stuff. So the GoTenna basically works off that principle, but the difference is you Bluetooth pair it to your phone, to your smartphone, and then you interact with other Gotenna users in the network that it creates, using just the app. And so basically, I'm kind of fumbling through this because it's a new thing. We do have a couple of these that we're testing for use in Codify, for doing some interesting things. But basically, you can see a map and you can cache maps onto the app. So if you're out in the middle of nowhere, you can still see maps there. But you can query the entire Gotenna network and all the Gotennas around you and find out where those people are. It's not real time as far as I can tell. So if you're looking at it, you won't see somebody moving, for example. But when they queue it, when they send you a message or they send out their location or you query locations, then you can see where everybody is. So that's pretty cool. And then also, the Garmin Rhino radio that I have does the same thing, but only to other Garmin Rhino radios. So anyway, you can also send text messages. I think with the newest Gotenna coming out, you can also send voice and images and things like that. So just like regular style text. And this is all without service, without satellites, without anything. They're just communicating with each other, which is pretty cool. So that's similar to something we talked about a while back. Chris, you talked about the Beartooth, I think it was, which is a similar device.
Yeah.
Yeah.
It sounds pretty identical, although in my opinion, not having used either of them, but just hearing the capabilities and whatnot, it sounds like Gotenna might have better performance.
Mm-hmm.
But we can go through some of the pros and cons of the Gotenna. I think we were having a conversation with Michael Ashley of Codify about the Gotenna, and is this the one that was kind of developed for special forces and like Spec Ops uses them for their stuff, or was that Beartooth? I can't remember.
Yeah, I can't remember either. I think they're both very similar though in the way they operate. So either one could have been. One of the interesting things about Gotenna versus Beartooth is Gotenna has a new device that's out on Kickstarter right now, called the Gotenna Mesh. So the basic Gotenna device, it's point to point from one Gotenna to the other Gotenna. So, and it's really kind of works in a radius. So if we're out working on a project or you're hiking or doing something, I can communicate. I can definitely communicate. It says usually up to 4 miles right here, 6.4 kilometer range, and that's a radius. I think the real world applications we've seen online are actually farther than that, depending on they're hedging their bets, to accommodate all environments. But if you're like out in the desert with no vegetation or hills and across a playa, it's probably a good 5 to 10 miles because there's literally no obstructions. But the thing is, it's just a radius around you that you can communicate. With the new Gotenna Mesh, you can actually relay messages through other users. So if anybody's seen like Lord of the Rings, when they light that signal fire and then all the mountain peaks light these fires, that's Gotenna Mesh.
So it's the beacons of Gondor or whatever.
Exactly. And that's a good way to think about it, because it's like it's you could be 20 miles away, but if there's 3 Gotennas in between us, Gotenna meshes in between us, then they're just at lightning fast speed. Well, faster than lightning. It's speed of light because it's radio. So, they're it's like almost it's real time. You don't even notice the lag going through other mesh networks, the other mesh devices, because it's like bam, instantaneous. So anyway, that's a really good thing, and I think it's probably less useful for archaeologists, because I can't imagine a time when we have people spread out in crews that are like, even at China Lake, we were never more than if we were on the same range at that project last year. We were never more than, probably real world distance 5 miles from each other if we were on the same range. If we were on different parts of the base, there's no way anything could have communicated with anything else, regardless of the Gotenna mesh. We would have had to have people in between us. So I'm not sure you need to upgrade to that for archaeology. And even Chris, probably on shovel testing stuff. I mean, how far are you away from somebody really? Your crews are never more than a few miles apart from each other, I would imagine, right?
No.
Yeah.
Yeah, typically not. I mean, there are the rare occasions of very large projects where you have maybe 2 or 3 separate teams working, very far apart from each other, stuff like interstate corridor surveys or, pipeline surveys where you've got, someone on one side of the state and someone on the other. But, that's a whole different bag of tricks
Right.
that, you know, you probably wouldn't even be looking at GoTenna for. But typically, yeah, you've got like one crew that's spread out. You know, if you've got, you know, even a large crew, you're only spread out every 20 or 30 meters. And, you know, I would imagine, you know, despite thick vegetation and whatnot, it's probably not going to diminish the performance of GoTenna that much. You know, probably only
Right.
a couple hundred meters away from the very farthest person.
No, I don't think even any terrain or vegetation would affect its reception at that range. I think it'd be perfect. So,
Yeah.
you know, we're looking at. I'm not going to reveal anything just yet, but we're looking at GoTenna for more than just communication as well, because it's got an SDK, which is software development kit, which means you can actually get into their code and do different things and make it do some kind of amazing things, we're thinking, and you know, for Codify. So we'll have more of that out later. And you know, Chris and I were talking. We're going to obviously be mentioning Codify a lot on this podcast because it's the Archaeotech podcast. But at some point, hopefully in the near future, look for this, and we'll have advertisements for it. There will be a Codify podcast, so where we talk about all things Codify, new features coming up, new things we're integrating with it, ideas, stuff like that. So, and also, by the time you're hearing this, our new website will have been out, and we've got some awesome things up on that. So go check that out. This isn't a Codify podcast, though, so let's move on. We'll have more out on GoTenna as we get to play with it, because I think this is a kind of a powerful thing. So, okay, well, let's move on. Chris, go ahead and talk about your app.
Yeah. So my app is Toggle. It's spelled Toggl. And it is basically a time clock for managing your tasks for work and whatnot. It's available on the Android and iOS platforms. I've been using it on the web-based, just the website there. It's pretty powerful and functional. There's a desktop app as well, and so it's really useful for me. You know, a lot of bigger companies have ways of entering your timesheets and whatnot. But sometimes it gets difficult if, you know, I think that this is going to be really useful for anybody who's in a project manager role, or, you know, even field techs. If you're jumping around on a bunch of little projects throughout the week, you know, I encountered that a lot back east, where, you know, I'd spend like half the day over on one project, you know, and maybe a bombing range would close down, so I'd have to move over to a different thing, and it would be under a different task order. So, you know, my timesheet would end up with, you know, for 1 week would end up with maybe 12 different billable tasks on it. So Toggle is just a very intuitive, easy to use interface on managing your different clients, your different tasks. You can edit everything from your billable rate, you know, the amount of hours that you can bill on stuff like that. And you can also set parameters where overtime kicks in. You can also enter tags on each of your things that you enter into your timesheet. And you can also keep, like, say if you enter, you know, you're working on project A, and it doesn't matter if, you know, you come back to it, you know, if project A is 40 hours for the week, then every day when you start your little timer, you know, you can just go click back on project A and continue the time. So it's like, you know, 8 hours one day, and then on the second day you pick up, you know, 8 hours plus whatever, so on and so forth. I hope that makes sense. But you know, when you log on to Toggle, it's super easy. And so, like, you can enter the tags on it too. So then later on, when you're going back and trying to figure out all that, you know, you can access everything really easily. I mean, the learning curve on it is almost zero. I picked it up in a matter of seconds. And you can also do a bunch of reports and stuff. So you can kind of export these really nifty little graphs that are easy to look at, you know, to anybody who needs to see them, or, you know, even just understand your own work balance, stuff like that. So I definitely recommend it for anybody who's having frustrations managing all of their time and their work. I also recommend it even if your own company has some kind of interface, because I worked for a company that had a web interface to manage time, and it just wasn't that effective, and it was still frustrating as hell to keep track of all my tasks. So I like it because it's like when I'm getting ready to start working on a billable task, I just go ahead and hit the play button basically, and it keeps the timer going. And when I stop, I just hit the pause button, and my time clock is updated.
Nice. Yeah, we use Toggle extensively with Codify between Michael, Ashley, and I. And the nice thing about Toggle is even if you don't have the app on your phone, which I actually don't even use it that much on my phone, because most of what I'm doing is on the computer. And the one thing that irritates me is Toggle doesn't integrate well with Safari, which is the browser that I use. But if you use Google Chrome, Safari is Toggle's an extension, so it'll add a little start-stop button up in your browser, and you can just tap that whenever you're working, and it will come up with the project. You can pick one or enter a new one, and then the Toggle timer will be running. And it also has integrations with other things like Trello. We use Trello in like these workflow boards, and on each different card within Trello, which is like a task card, there's a start toggle timer right there. So when you're working on that card, you can just hit the start, and it will automatically start working on that card. And the cool thing is, from a workflow standpoint, you don't have to hit stop necessarily. You can just close that card, and when you open up another card and you start another toggle timer, it will automatically stop the last timer and start the new timer, so there's no gap in the time, because those gaps could actually add up if you're trying to use some billable rates here. So that's a good thing to know, is unless there's like a pro version or something, from what I can tell, only one toggle timer is running at a time. So if you do start a new task, it will automatically stop the last one and start the next one, like almost exact, with no time lost whatsoever. So yeah, it's pretty great. And if you use the extensions, like I said, on Chrome and different applications, then you can really do a lot of good stuff with it. But yeah, well, that's cool. And Toggle's free to use. I know there are some paid versions of it where you can get a lot more functionality, but from what I can tell, most of it's pretty much free. So that's also really cool. GoTenna, I forgot to mention, the app is free to download, of course, but the GoTenna device is, depending on where you find it, anywhere from $149 to $200 for two of them. And you need two of them, obviously, to do anything. So just one of them won't do you any good. But check them out. They sell them online. They sell them at REI and all over the place. And you can also find them on eBay, because people are buying them and not really understanding what they're used for, and then selling them back. So they're like, this is cool. Wait, what do I do with this? All right, I'm going to sell it. It looks like a Sharpie. Yeah. It's not a Sharpie. All right. So anyway, that's it for the Archaeotech podcast today. Come back later. And again, like I said, we'll have some... hopefully if you're interested in technology, look for the Codify podcast, hopefully coming out soon, and we'll be advertising for that on here. All right. Thanks, Chris.
Yep.
All right. Talk to you guys later. That's it for another episode of the Archaeotech podcast. Links to some of the items mentioned on the show are in the show notes for this podcast, which can be found at www.archaeologypodcastnetwork.com/archaeotech. If you like the show and want to comment, please do. You can leave comments about this or any other episode on the website or on the iTunes page for this episode. You can also email us at chris@archaeologypodcastnetwork.com or use the contact form on the podcast webpage. If you'd like us to answer a question on a future episode, email us. Use the contact form on the website or tweet your questions with the hashtag Archaeotech or tag @ArchPodNet in your tweet. Please share the link to this show wherever you saw it. If you'd like to subscribe to this podcast, you can do so on iTunes or on Stitcher Radio. You can also type the name of the podcast into your favorite podcasting app and subscribe that way. Don't forget to go over to iTunes and leave a review of the show. It helps us get noticed so more people can find our podcast and benefit from the content. Also, send us show suggestions and interview suggestions. We want this to be a resource for field technicians everywhere, and we want to know what you want to know about. This show is produced by Chris Webster and Tristan Boyle.
This has been a presentation of the Archaeology Podcast Network. Visit us on the web for show notes and other podcasts at www.archaeologypodcastnetwork.com. chris@archaeologypodcastnetwork.com. Contact us at chris@archaeologypodcastnetwork.com.
Thanks again for listening to this episode and for supporting the Archaeology Podcast Network. If you want these shows to keep going, consider becoming a member for just $7.99 a month. That's cheaper than a venti quad eggnog latte. Go to arcpodnet.com/members for more info.